right, we are ready for indicator 15. We are ready for our last indicator of the semester. So we just have a few lessons. We're going to break it down into a few days. And we are still solving systems of equations. So we're going to have two equations, and we're looking for that solution that works for both equations. If you think about it graphically, it's that point of intersection. And I'm going to show you guys another way to solve. So we have solved by actually physically graphing them and finding the point of intersection. That was indicator 13. And then in indicator 14, you learn how to solve them with elimination, or substitution, I'm sorry. Substitution, where we plugged in things that we knew into the other equation and solved. And then our last type is elimination. Honestly, elimination is probably the most common because it's a little bit faster. And in real life, most equations are written in standard form, and so it just kind of makes more sense to solve them this way. So whenever we are solving, elimination means that something cancels or equals zero. If they eliminate, they're gone. So we are actually going to be looking for opposites here. We're going to be looking for positives and negatives that equal zero. So like a positive 3 cancels out with a negative 3. A positive 6 cancels with a negative 6. And this is what we are going to be looking for. So we are going to have examples, and I'm just going to start out with one that's pretty simple, just because I think you guys will know this. So I want you guys to tell me what two values, if I add them, so a value for x and a value for y, let's say we get 15. So there's lots of different ways, different numbers that you can add to get 15. You could use, it could be 10 and 5, it could be 9 and 6, it could be 8 and 7, 12 and 3, 14 and 1. Lots of different ways to add to 15. Now, I'm going to add a second equation in, and it's going to limit our choices. So I want to know a value of x and a value of y. When I add them, I get to 15. But when I subtract them, I get 3. So earlier, the first thing that came up in my mind was 10 plus 5 is 15. So like x is 10 and y is 5. This isn't going to work here because 10 minus 5 doesn't give me 3. I want to find a number that fits both of those, and if you guys think about this for a second, maybe you know it, maybe you don't. But these are actually 9 and 6. So we know that 9 plus 6 is 15 and 9 minus 6 is 3. Now we can actually solve this using algebra and doing this elimination. So we actually, what we do, and this is really strange, we just combine the two equations together. We add the like terms. Now we can't add like terms unless something eliminates. And the reason why we want to do that is if something eliminates, then we can solve for the other variable. So if we want to look at these, right now we have a 1x here and a 1x here. They're both positive. Elimination only happens if you have opposite signs. Now if we look at the y's, we have a positive y and we have a negative y. And so those eliminate. A positive 1 and a negative 1 becomes 0. So those are actually going to be what eliminates here. So then we just combine what's left. We add them. 1x and 1x becomes 2x. 15 plus 3 is 18. And then we can divide by 2. And we get the value that x is 9. So we know that if we were to graph both of these equations, we could have done it by hand and graphed, or you could use Desmos, but we know that the x coordinate is 9. Now, we have to find the y coordinate. If you have two variables, you have to find them both. So if you want to find the y coordinate, you simply just pick one of the original equations to go with it. Honestly, doesn't matter which one. So I'm actually going to show you with both equations. So if I chose the top equation, x plus y equals 15, I now know x is 9, so I can plug in a 9 for x. And then subtract my 9 over, and I get y is 6, which that's what we said it was going to be earlier. But I just wanted you to see that. Now, If you had chose the second equation as your choice to plug in numbers, you would have plugged in a 9, minus y equals 6, subtract your 9, and you get negative 1y equals, what did I mess up? Oh, because it's a 6. No, x is 9. Oh, I subtracted here. Sorry about that. All right, so we subtract our 9, and we get negative 9y equals negative 6, and then we divide by negative 1, and we get a 6. So it doesn't matter which equation you pick. Once you know the first variable, you simply just plug it in to either equation, and you do not have to solve it twice. You only have to solve it once. I'm just showing you you have two options. So you would plug in what you know, and we now know x is 9 and we know y is 6. So if we wanted to graph that on Desmos, the point of intersection would be 9, 6. So this applies, it doesn't matter which one cancels. It could be the x's, it could be the y's. You just, whichever one eliminates, you solve for the other variable. So let's do a couple more examples like this. With this elimination method, I really like this. This is probably one of my favorite topics to teach. I don't know why. I just like them a lot. Now, if we want to look, I want to find one that's a little bit better. Okay. 5x minus 6y equals 16. Oh, I don't want to do that one. Sorry. That comes out as a fraction. We don't want that. All right, how about this one? 2x plus y equals 4. And negative 2x minus 2y equals negative 2. So if we look at this equation, if you can see, if we look at our coefficients, at this point, if we wanted to combine, we want to find one that equals 0. So we have a positive 2 and a negative 2 here. This does equal 0. So that eliminates. A positive and a negative cancel each other out. So now we just combine what's left. So we have a positive 1 and a negative 2, or you can think of that as 1 minus 2, so that's negative 1y equals a positive 2. 4 minus 2 is 2. So then we divide by negative 1, and we get y value as negative 2. So then at this point, you can choose either equation. I'm going to choose the top one just because I like working with positive numbers whenever possible. So I have 2x plus y equals 4. So I now know my y value, which is negative 2. And if you want to just write that as 2x minus 2, it's a little bit easier to read it that way, because it's plus a negative or minus. So then I add my 2 over, and I get 2x equals 6, and I divide by 2, and I get an x value of 3. So I have my x value, I have my y value, so my final thing I need to do is write my solution as an ordered pair. So it's positive 3, negative 2, and there we have it. So positive 3, negative 2 would be our solution. And now I do want to show you guys, if you wanted to open up and check your work, you simply just type in the original equations into Desmos. So you just open up that graphing calculator, and in your equations, my first equation is 2x plus y equals 4. So we got that. And then my second one, negative 2x minus 2y equals negative 2. That gives me my second line. And then we look for that point of intersection, which is positive 3, negative 2. It's just a simple way to check your work. You obviously have to have your work to back up your answer. But while you're at home and you have questions on something, you always can use this as a way to check your work. All right, so now I want to go over the second type of problem you're going to see today. So far, everything we've been able to eliminate something. Now, the second situation is when you might have to do some subtraction. So if we look at this, we got 5x plus 3y equals 10, and negative 2x plus 3y equals negative 4. All right, so obviously a 5 and a 2 would never eliminate with each other. But a 3 and a 3, it's close, but not quite. In order for these to eliminate, you have to have opposite signs. So right now we have two positive 3's. In order to make these eliminate, you can actually, one of them needs to be a negative. All right, so I'm actually going to make, and I'm writing it in a different color just so you can see this. Well, I'm actually going to do this, make it a little bit easier to see. So I'm not going to change my top equation at all. I'm going to keep it all positive. Now, I actually want this 3 on the bottom. Right now it is a positive. I actually want to make it a negative 3y. We can do this. If you change the sign of this, you can actually do that as long as you change the signs all the way through. So this negative 2, you can change it to a positive 2. Then that positive 3 became a negative. And then the last step, that negative 4 becomes a positive 4. All you have to do, if you need the signs to be opposites, it's okay. You just have to change every sign in that bottom equation or the top equation, whichever one you choose to make different. So whatever you change, you just have to change it all the way across the board in that equation. So here we changed every single sign to the opposite in order to, because whatever you do to one number in an equation, you got to do it to the others to keep it balanced. So now we have this elimination. Our positive 3 and negative 3 cancel. So now we're just going to combine what's left. This is two positive numbers, so that's like positive 2 is a plus. So that's a 7x, and then a 10 and a positive 4 would become 14, and we would divide and we get x is 2. So that's part 1. We've got x is 2. Now I just pick an equation, and I'm going to pick the top one. But I now know my x value is 2, so I can plug that in. And I get 10 plus 3y equals 10. Subtract my 10 over, and I get 3y equals 0. Hey guys, what's 0 divided by any number? It is 0. So my x-coordinate is 2. My y-coordinate is 0. You can have a 0 in your solutions. So I just want to go back and show you on Desmos, checking this work. 5x plus 3y equals 10. There's equation 1. And then I have negative 2x plus 3y equals negative 4. I just put in those two original equations. And if you can see, I have 2, 0. So just make sure when you're checking your work on Desmos that you do double check your signs as you're plugging those in, especially whenever you're changing signs. So I have a couple more to show you guys, and then we will be done for today. All right, so the first one I've got on this one is, all right, 5x plus 3y equals 10, and 5x plus 3y equals 4. Now, obviously, nothing eliminates here. But right now we have two positive 5's and two positive 3's. Now if I want to make these a negative, I can just make them a negative all the way across. And if you want to show your work that way, that's okay. So my x's, I now have a positive 5 and a negative 5. It becomes 0. All right, I have a positive 3 and a negative 3. That becomes 0. So we actually have nothing left on the left-hand side. And on this side we have a 6. Can 0 ever be equal to 6? I definitely don't think so. This is definitely a false statement. So we say no solution. And just like always, we can use the symbol. So if you guys remember from the graphs, the solution is always the point of intersection. So if we have no solution, the lines don't intersect. So if we go back to these are the two originals. We have parallel lines, and that's why we have no solution. All right, and last but not least, if I have something like this. All right, very rarely do you have something like this, but look at what happens. A positive 3 and a negative 3 becomes 0. A positive 4 and a negative 4 becomes 0. A positive 8 and a negative 8 becomes 0. Now, we have nothing on either side. Now, this is a true statement, and this is actually something that we didn't talk a lot about in graphing, but whenever you have everything eliminate, they actually graph to the same line. And we actually write infinitely many solutions. Now, if you want to abbreviate, I will allow it. So that is the abbreviated version, infinitely many. So you can have ordered pairs, you can have no solutions, you can have infinitely many solutions. More times than not, you're actually going to have an x and a y to solve for. But I'm going to give you guys one more. I thought I said one more for the day. I lied. I just want to give you one more elimination problem. And honestly, once you have this down, hit pause, try it on your own, and then check your work to see how you did. No, I want to find a good one. All right, I want you to hit pause, try this one on your own, and then whenever you're done, you can watch me go through it. So everybody hit pause and get to work. All right, so I am ready to continue. So we have a positive and a negative 5, which eliminate. So what we are left with is a positive 1 and a positive 3, which makes 4x. And then a negative 11 and a positive 7 become negative 4. And then divide by 4, and I get x is negative 1. And then for the second part, again, it doesn't matter which equation you pick, but I'm actually going to pick the top one. But I now know my x value is negative 1. Oh, should have copied the original down right. Happens more times than not. And then I divide by 5, and I get my y value is negative 2. And then do not forget to write your answer as an ordered pair. X always goes before the y whenever you're writing your solutions. So this is what we're doing today, and then each day next week we are going to be adding another step. Obviously, not everyone has like a perfect 5 and 5 that eliminates, so we're going to do a little bit more work. But if you guys have any questions, don't hesitate to reach out, send me an email, whatever you need. And if we need some one-on-one instruction, we can set up a Google Meet. I hope you guys have a great weekend, and I will be back on Monday with more lessons.